and welcome to today's webinar, Launching Database as a Service on Your Cloud. My name is Jack Allen, and I will be your moderator for today. Joining us are Sandeep Patney and Chip Childers. Sandeep Patney is the co-founder and VP of Systems at Cumulogic. Prior to Cumulogic, he has spent more than 11 years at Goldman Sachs in various infrastructure roles and as an application infrastructure architect for Risk Technology. Chip Childers is the Vice President of Product Strategy of Cumulogic. Chip's previous roles was as Chief Architect of SunGard's cloud service offerings. He also served as the first Vice President of Apache Cloud Stack for the Apache Software Foundation. Throughout our presentation today, we encourage you to submit questions using the questions pane on GoToWebinar. We will answer questions live at the end of the presentation. Please keep in mind that all participants are in a listen-only mode. We are recording today's session and will email a link to the recording tomorrow and post links on the Cumulogic website. Let's get started. We'll kick off today's webinar with Chip. Chip, all yours.
Thank you, Jack. Fantastic. Glad to have everybody here. What we'll be doing is going through a little bit of an overview of database as a service, generally in the market, how Cumulogic can help you offer that very quickly. Then we'll hand off to Sandeep to give you a demo of the product. And then, as Jack mentioned, then we'll take questions near the end. So just look at the market opportunity for you as a service provider very briefly here. 451 Research had done a report that talked about the database as a service market and some of its forecasts for projected growth. It's really an amazing segment of the cloud services market if you consider that it's growing at approximately 100% year-over-year growth, and those predictions make it easily past the $1.5 billion annual revenue mark by 2016. And so that's very, very aggressive, and that means that there's quite a lot of opportunity out there for service providers to take advantage of this growing demand that the Uber providers out there are driving for everyone. When you look at enterprise adoption, this is actually one of the more interesting facets of the study. In 2013, about 32.6% were already using database as a service functions, and so that's expected to grow to 70% by 2016. It's rapidly becoming both expected and almost required by cloud users when they are making a decision about where they're going to put their applications, which cloud provider they'll be working with. And one of the questions that's been asked of Cumulogic as we've been speaking with service providers around the globe is, they want a better feel for exactly what's driving end users to expect database services out of their cloud operator. And again, we'll go back to both 451 Research as well as some of the qualitative information that we've been able to gather as a company. What 451 Research is showing is back in 2013, out of all of those companies, those enterprises that were making use of database as a service, clearly a large chunk of that consumption is going to be driven through dev and test systems. But at about 36%, production web applications are a very strong use case. Now remember, this is 2013, and so that production level use is going to continue to grow. And then there are other reasons: additional capacity, focused on making it simple to build out analytics systems, backup and DR options, as well as departmental apps. But clearly, the focus has become the kind of the dev and test environment and the production web applications. And since most development is occurring for web applications, that becomes the focus of what database as a service is supposed to support for the users. Now, if you flip it and you think about what exactly is it that database as a service is solving for the end user, not what workloads are they putting on it, but what problem is it solving? There's a very clear picture that we can paint. So the first is that within the enterprise, application-specific databases are growing rapidly. Every time a new line of business application gets built or a custom web application is built, very likely it's got at least one database that's brand new that needs to be created and supported and backed up. And because of that pressure, being able to allow the application teams to consume databases in a very simple, abstract way and trust that it's being backed up and that it's got high availability built in is very important. Now that's, of course, leading to massive growth in overall stored data, which is really just making the problem exponentially harder for IT shops. There's also an increase in velocity of change in the application layer. So we all know that as applications are being rebuilt as web apps, the friction to deploy a new web application or to change that application really has become a lot less, which means that we're seeing an increase in change. It's a great thing for an application owner as they're going through changes to be able to quickly use a database as a service system to snapshot an existing production database, restore it for their new QA or dev environment. And so DBaaS really ties into the application workflow, the application development pipeline processes very nicely. And then, of course, there's the challenge of operationally supporting the newer database technologies. And so that largely we're seeing on the NoSQL database front. We'll talk about some of the databases that we can allow you as a provider to support. But your customers are going to be struggling today with their developers grabbing MongoDB or Couchbase or expecting more from a MySQL environment than their DBA teams might be able to support based on current knowledge. And so we can help address all four of those major problems. So our value proposition for service providers is very focused on 3 points. First, we want to help you enter the database as a service market quickly. And we'll talk a little bit more about this later on, but we've got a 30-day program that can set you up with the potential for generating new, higher value, recurring revenue. Second, applications want to live close to the data. Developers want their app to be running near the database. The reason for that is clearly latency impacts how you work with the database, and it just makes things simple to single source from one provider. So by offering database as a service, you as a provider are going to see an increase in the overall cloud services consumption, and that's additive to any of the capabilities you're offering as a service, whether it's just simple virtual machines or whether you've added object storage or other as a service functions. And last, we really believe that database as a service is rapidly becoming required from cloud service providers. It's becoming an expectation, and if you understand that over 70% of enterprises will be using database as a service by 2016, that means that you need to be offering this as well. And so we're here to help you do that. Let's look at the Cumulogic platform at a glance. So Cumulogic is a software company who is really on a mission to enable cloud operators to deliver the types of services that complement existing VM-based as-a-service clouds very easily. We have a strong focus on SQL database as a service as well as NoSQL database as a service. That's what this discussion today will be focused on. We do offer some additional complementary capabilities such as caching or message queuing. They tie in very nicely to that database story because web application developers want simple access to a database, but they also want to have simple access to a caching cluster or message queues to make calls asynchronous. Both of those technologies really allow for highly performant web architectures. Our platform architecturally is conceptualized as really 3 different layers. At the bottom, we work with a large number of infrastructure as a service platforms. We can work very well with the VMware suite of tools, Citrix Cloud Platform, CloudStack, several OpenStack distributions. We recently announced that we are supporting the latest OpenStack release, which is Icehouse. We also work with Eucalyptus. We can work with pools of bare metal systems or pre-provisioned virtual machines. Bare metal systems can allow you to offer guaranteed performance and eliminate any contention between virtual machines, whereas the pre-provisioned pools of VMs might allow you to work in environments that aren't as orchestrated as some of the software stacks that I previously mentioned. And last, because we support the APIs of that software, we're able to work with a large number of public cloud providers as well. You could be one of those providers so that as we're working with the enterprise, you could easily be the target for development and test environments. Moving up the stack, we've built everything to create a very common framework for all of our as-a-service modules. This allows us to abstract all of the infrastructure details, handle automated operations, task management. We have a security framework that applies to all the services. And so each one of those capabilities then gets to plug into this core framework. So our modules, SQL Database-as-a-Service, NoSQL, Elasticache, message queuing, and others are in fact plugins to our core framework. You could choose to go to market with all of these capabilities, or you could choose to go to market with simply one or some. But our framework can support you depending on what you want to offer to your customers. At the top layer, we're going to be demonstrating our user interface. That UI can easily be branded, white labeled, to look like your company's brand, to make your customers understand that it's your service. But our controller is actually exposing RESTful APIs up to that UI. And so what some of our provider customers are doing is they have an existing portal that they transact business with their end users. They use to transact business with their end users. And they're integrating our controller as really just purely a control plane, and they're extending their existing user experience. So you've got a lot of options about how you tie the Cumulogic capabilities into your broader architecture. We'll spend a little bit of time diving deep into the relational database as a service. Then we'll go and look at the NoSQL service. We'll talk about a 30-day program, and then we'll jump over to Sandeep with the demo. The Cumulogic Relational Database as a Service module is designed to allow for an Amazon RDS-like experience for your end users. Amazon RDS is widely used. It's extremely popular within the communities that are using Amazon. It's what really allows the power of the Amazon infrastructure to add a lot of managed functionality and to abstract away the details of how do you configure a new database, how do you manage multi-node clusters. And so that's exactly what Cumulogic can do for your users and for your operations. The basic premise of the software is that it supports anything from a very simple, single-click, name the service you want to instantiate and ask it to launch model, to a much more feature-rich walkthrough of discrete features that are being selected by the end user, sizing of the nodes, tuning of specific configurations. So anything from a very simple experience to a more advanced user's experience. The provisioning process can, again, be as simple as ask to pick a particular package, name it, and say launch. And what our platform will do is it will take care of provisioning the virtual infrastructure necessary to service that request, and then deploy the appropriate software to one or more virtual machines. In the case of a single node MySQL database, that's one VM. We'll push the MySQL software plus configuration, start it, hand control back off to the user. In the case of a multi-node environment, whether it's MySQL replication topologies or whether it's Percona clustering, we'll accomplish the same steps, except this will be multiple virtual machines, and then we'll orchestrate the configuration of either the replication jobs or the cluster itself. And then Cumulogic doesn't stop there. Once that database has been deployed or the service has been provisioned, our platform takes care of a number of automated tasks. We monitor for performance. We monitor for capacity. We also monitor for availability. And in the case of a multi-node high availability deployment, we'll automatically self-heal around any fault on behalf of you for your user. Today we support both MySQL and the Percona engine. In Q3 we'll be releasing support for both Oracle as well as Microsoft SQL Server. Digging a little bit more deeply into the features, I believe we mentioned most of these already. So high availability architectures are possible. Multi-data center, multi-cloud, multi-zone aware topologies are also possible. And we'll dig into that use case in a little bit. We can automate backups. We can provide both snapshot-based backups as well as point-in-time restorations. And we mentioned that we'll be able to do automated failure recovery in the case of a high available architecture. And we also offer a number of self-service functions back to the user once the service has been provisioned. So that includes things like cloning the database in order to deploy a new version of it. That helps with developers pulling data back from production for the purpose of test or new development. We can roll back to a point in time. We can also allow the end user to scale the environment by adding new nodes, new replicas. And last, we do provide visibility for your users into things like slow queries, or getting access to audit logs or access logs for the engine itself. Quickly, we'll just look at a few architectures that are possible beyond single node deployments. In this example, what we're looking at is a multi-data center cluster setup for Percona. The application is able to target any node of the cluster. In this scenario, the second zone is also included in that cluster, which allows potentially for different use cases. That could be there for the purpose of a disaster recovery failure scenario. It could be there for deploying the application into multiple locations with geographic load balancing in the front. Lots of reasons to have multi-data center capabilities. We're particularly happy with our multi-zone replication with automated failure function as well. This is automated DR for your database. In this scenario, we've got two different data centers with a database read-write as well as a master-master replication for a standby master. What we've done is we've set the application to communicate with the hostname provision for the primary database. And assuming everything's healthy, communication from the app will talk to MyDB, in this case, mydb.cumulogic.net. Now, in the event of a failure, this could be a zone-wide, data center-wide failure, or this could just be an individual node failure that causes the service to be unavailable in the primary data center. Cumulogic will automatically perform a DNS endpoint change. The application will be able to reconnect to the secondary node and begin to service customers again. Once we've noticed that the original failure has been remediated, we're able to recover as well. And that involves deploying or recovering the initial node and reestablishing that replication scheme. The other possibility here is to, depending on how you deploy the Cumulogic controller, you can offer your customers a off-site backup location, which allows for both continuous backup as well as those point-in-time restorations in a secondary site. So that's all we're going to talk about today with the relational service. We'll spend now a few more minutes on the NoSQL service. This service has been designed to support two different NoSQL engines, MongoDB and Couchbase. Both are very popular with developers today. Lots of traction in the market. We're running into Mongo and Couchbase on a number of different enterprise accounts, and we're working with service providers around the world that want to offer these two engines in a very simple way without having to create the type of managed database service that requires them to staff teams of expert DBAs that has been traditional in the managed service industry. The capabilities are designed similarly to our relational service. The specific parameters and architectures that are possible are going to be tuned for the way that NoSQL engines want to work, although you can expect the same type of simple provisioning and automated operations that you got from the relational service. We'll dig in a little bit deeper to MongoDB. It tends to be a very popular database, as I mentioned earlier. We also have a very strong relationship with Mongo. MongoDB is a partner of ours. And working with them, we've been able to make deployment of MongoDB almost zero operations. We can deploy scalable replica sets. We can do even advanced sharding architectures, and we'll dig into some of the architectures momentarily. We allow for elasticity, both within a shard as well as by adding additional shards. We can do multi-region, multi-zone, multi-cloud deployments. And then again, all of the same health checks and monitoring capabilities we talked about with relational systems are available here. Deployment architectures, similar to what we saw with the Percona example for a relational service. Here we're looking at a multi-node single zone replica set that allows the application to work with both the primary as well as the secondary MongoDB instances. That same type of architecture can be deployed across multiple data centers. And then the real complex deployments that are possible with Mongo are just as simple for your users to deploy. And this is where a database becomes, reaches the point that it really has to scale up as well as scale out. So Cumulogic's made it very simple to deploy what this architecture is depicting. This is a sharded cluster within a single zone with multiple servers and replica sets being managed. The components that the Cumulogic controller will deploy on the user's behalf include the MongoDB-as system, effectively the query routers that the applications will communicate with, the config servers and the monitoring agents necessary to maintain the environment, as well as each of the nodes that make up the replica set that is for each shard in the environment. And again, we can self-serve scaling both within the shard as well as by adding additional shards. So backing up again, let's repeat what the Cumulogic value proposition is for you. We're going to let you enter the market quickly. Again, we have a 30-day program to do that. Once you have database as a service available for your customers, you're going to see an increase in overall cloud service consumption. And really, database as a service is rapidly becoming a required function that your users are going to come to expect over the next several years, if not sooner. So our 30-day program for service providers includes the deployment of the Cumulogic platform. We can work with you to do UI customizations to match your brand. We'll support you with co-marketing activities. We'll provide you with operator training for both the platform as well as the self-service functions. And of course, we'll be there with technical support for our software. We're running a special offer until June 30th of this year, where we're guaranteeing a 30-day standard production deployment. We've got 50% off our setup fees and deep discounts on the software licensing. It's going to depend on the scale, and we have a few different models that we'll use for how you might want to work with us to license the software, but you can expect very deep discounts during this special promotion. Now with that, I believe we're done with the slides, and I'm going to hand off to Sandeep and allow him to walk through the presentation.
All right. Thank you, Chip. Hello, everyone. I'm Sandeep Patni, co-founder and VP of Systems at Cumulogic. In this part of the webinar, I will show you how easy it is to set up and manage database as a service with Cumulogic. What you're seeing here is the Cumulogic user dashboard. So Cumulogic makes it very easy for service providers to provide SQL and NoSQL database as a service on any cloud to their customers. Now, users can launch a dedicated MySQL or MongoDB service and optimize it for their particular workload as needed. So Cumulogic allows you to provision and manage all these database services from user interface like what you're going to see here and the command line tools or the RESTful APIs. So now let's go ahead and see how we can provision and manage these database services. So here from the user dashboard, I'm going to go into services. So under the services, now we can see on the left hand side, I have SQL and NoSQL database services available. We'll walk through both of these and the functions, features, how easy it is to provision and manage these services. Now what you are seeing here is some services which are being provisioned. Let's go and first try to provision one service, and then we'll come and look at some of the functionality which is available. I'm going to go here into the launch instance. From here, we can walk through the provisioning screen. I'm just going to go through quickly and show you some of the features. I'm just going to call this some database name here. Give it a name, give it some description. From the engine drop down, choose what engine you want to make available. So I have Percona, and that engine I'm going to select. Percona, for example, here on the target cloud, I pick what target cloud. Now users have already set this up in their account as a service provider. You can pre-populate the user's credentials so that they can communicate with your underlying IaaS infrastructure to provision those resources. Once that cloud is available, if you have more than one zone or VDCs available in your cloud, you could provide that to your users, and users have a choice to select which VDC or which data center they want to deploy this particular workload. Like you saw in the slides, you can have a single zone deployment, provision all the nodes in a single zone and have that as a cluster, so get you the flexibility and the scale. At the same time, if you wanted redundancy and you wanted to provision the database into two different zones so that you're protected from a zone failure or a data center failure, you could click on multi-AZ support and choose the secondary zone if that's available. So let's go further from here. User can choose the instance types, so you could provide them instance sizes available in your cloud, whether this is customizable by the by you as a service provider, what sizes instances you want to make available for the users. Service tag is just identifying what kind of environment user is provisioning. In the bottom section, user can provide their username, master username, password, some default schema that to be created. Go from here. In the next screen, user will provide a pre-configured parameter group if they have any created. So I have a parameter group here. I can show you that I'm just going to choose what I have created. We will see how we can edit that in future. So storage and backup, we can user will provide the storage information, so the size of the database they want to start with, and then if they want to configure the database with the backup option enabled. So once the user enable this backup, then they can choose the retention period and the backup start time. So as part of the provisioning, the backup will be configured so that at that specific start time, the backup will kick in and the database will be backed up. Once all this is done, user can click on finish to start provisioning that database. So I'm going to cancel here, come back to the database provisioning. So we saw how you can provision whether it's a standalone database instance, a Percona multi-zone deployment, or a Percona cluster. So on the screen here, you can see that I have some database which is already pre-provisioned. So let's look through some of the functions which are available. So I have some database which is provisioned here. When you click through launch that instance, under the hood, Cumulogic controller will connect to the IaaS infrastructure or your vCloud infrastructure. It will create that virtual machine, create the storage, configure backup if it is defined, configure monitoring, and based on the configuration selected, whether it is a cluster, it is a master slave, or it is a multi-zone deployment, the required configuration will be done. And once the setup is ready, the status will be turned green and handed over to the user for access. Now, throughout the event when that is happening, the users will be able to follow the progress in the event log. So this is where they will see that instance is getting created and configured and so on. If there is any problem during the provisioning cycle, that error will be made available here, and that can be used for reporting it to the support, and then your support team can based on the error you see here would be able to act upon and resolve the issues for the users. Monitoring tab will show the monitoring data. Logs, as the name says, you have access to the log information, the slow query, general query log, and MySQL log is available for users to see. You can see it here on screen, or you could download that for analysis outside the system. Usage metrics is where it will show you the usage on the database, how many schemas are created, how much space they are taking, how much space is available, and so on. And most important one here in the bottom pane is the access details. Access details is where user can get information, the access information, the DNS endpoint, the port number, username, and password for that given database, where they can connect to the database from their application or from their workbench to create schemas, upload data, and so on. So this is about the access and view into the database. Now let's see the other management functions which are available on this database. Now you can see that I have a standalone database which is provisioned here, and I have one Percona cluster that is provisioned. So the access information is available for a cluster here as well. Now so it makes it very easy for end users, make it self-service. So there's a least hand-holding required for a user to be able to provision and manage those database services. So people can do, the users can do it on all by themselves without having the need to have an expert DBA looking over their shoulders. So from here, I can go, and now I'll just show you some of the actions which are available on the standalone database instance. When I provision a standalone database, I can have expand that by adding the replicas to it. So creating read replica is, and if I go through that screen here, creating a replica, I can give it a name, choose which zone, so I can deploy a replica in another zone if that's available. I can choose the instance size, and I can specify the storage required for that. So by doing that, it will create an instance in that given target location and configure that as the replica node for the and configure this as in a master slave configuration. And once the replica is ready for use, it will be made available in the replica screen here. You would see that I have a replica, which is now users can take this access information. Similar access information is available for the replica, but this is a read-only. So now users can point their read-only functions to the replica and the read-write to that the master node from that setup. And you could add multiple replicas in different availability zones or clouds and such. In the monitoring section for the replica, you can monitor how that replica is doing, if it is behind the master, and if it is sync and stuff. And you can also the controller is automatically monitoring the replication status, and it will manage and recover if there's any replication issues in that. Now, while the replica is provisioned, you can always go and say, if you're done not using that replica, you could terminate that, or you could promote a particular replica to a master and use that as a standalone instance. Coming back to the databases here, some of the other actions we can see here. Modify is where you can modify your backup options, or like I was mentioning about the parameter groups. So if you provision something with the default parameters, you could always come back and add a parameter group. What that will do is, parameter group is a set of performance tuning parameters. Now you could apply them to a running instance, as well as you could use that during the provisioning itself. So you could pick that up and say, apply this right now, or just save it and apply it later during the next maintenance cycle. So I'm just going to go and apply that right now. So we would see that the parameter group is getting applied. Now we can see that small db is being applied. So any parameters I have specified in that small db parameter group, those will get applied to that database now. Now coming to the cluster, we started provisioning this cluster with the 3 nodes, and I have that up and running right now. But as the need grows, we want to scale it up, so users can go and do add node. They can grow that cluster, or once they have more than 3 nodes available in that cluster, they would have an action available called remove node, so they can basically go and shrink the cluster as needed. Some of the other actions, very simple: restarting the database, creating a clone of the database, and terminate. So terminate is basically will terminate the database resources and the virtual machine storage and return that to the cloud. So the the billing will stop at that point for the users. So during the provisioning, we saw you can configure the backup. So automated backup is created, and the backup will be taken, and they will be available here in the snapshot section, where user can pick up this, either restore from the snapshot or delete it if you don't need it anymore. Also, so that snapshot is happening at the specified interval in the automated mechanism, and it will have that retention time as specified in the configuration. But if somebody wanted to take ad hoc backup, so you could also take the ad hoc backup from here, create snapshot, and select a particular instance you want to take a snapshot of, and create a snapshot right from here. Also, a restore function is available, so you can restore, you saw from the snapshot, you can restore it directly from a given snapshot, or you could always restore it to a particular point in time with a more granular time window, and select a particular time and restore the database. So very powerful backup and recovery functions are made available as part of the default provisioning, when user can just choose enable backup, and this is all made available to the users. Now quickly walking through parameter groups, let's take a look in the parameter groups. I have so you could create a parameter group by just making a copy of the parameter, the default parameters which are exposed for a given target. And once you have made the copy, like we saw, you could go and edit those parameters. Now in the view edit section, you would see that all the parameters which are made available, there's about all MySQL 200 parameters are made available here. So you can see that, for example, I have changed a very simple parameter, MySQL connection, max connections. It is 150 right now. I wanted to change it to 300, or let's say I wanted to change it to 400. I can say save this right now just, or we can apply it later, or I could just say apply. So if any database instance is using, like DemoDB1 is using that small db as the parameter group, it is giving us a warning that if you apply this, if one of these parameters needs a database restart, it will get restarted on that database. So we say yes, and very simple for you to fine-tune your database based on the performance requirement on your database. Access group is simply the firewall control access on your database, so it shows you what ports are open. You could go and edit this the access group after the provisioning to control the access for your database. So this is on the MySQL database service side, where you can provision a standalone, a cluster, a multi-zone deployment, and manage that with all the functionality which is available. Now let's quickly take a look at the NoSQL service. Here you can see it makes it very easy to provision complex MongoDB deployments like the replica sets or shards, and having the multiple shards, and that makes it a breeze to deploy that with few clicks. So again, users can do this with few clicks on the service. Let's take a look. Some of the other functionality, as you will find, the parameter group, access group, and all of that is consistent with what we saw in the MySQL service. So let's take a look quickly, and then we'll how to provision a service and the configuration options available. Click on the launch instance, give it a name, give it some description, choose the engine. So I have Mongo and Couchbase databases which are available in our NoSQL service. So you could click on Mongo. There are different types of configurations available. I could just pick a standalone configuration and just start off with a single Mongo node, and then grow that in automatically. From there, I could add more nodes to it to grow it, make it a replica set, and make it into a sharded cluster. But from the get-go, if I wanted to provision a replica set, I could click on replica set and choose the number of nodes I want in my replica set. So I could go and provision the number of replica nodes I want. Or I can provision a sharded cluster. So I have two choices. One is a production shard and a development. In a development shard, it would be just one query router, one config server, and a single shard node. You could always add more shards to it. So that's the smallest configuration you can start off in development testing. But if you wanted to go and deploy a production sharded cluster, then you would see the number of nodes here has increased to 9 already. What that will do is it will take make the redundant config servers and query routers, and also create a shard as a replica set, so to give you that production redundancy and availability. You could always start off with a smaller node, like I said, and add add more shards or add more nodes to make it a replica set. So let's go ahead and try to provision a shard. Go through this provisioning here. Click on similar options like choosing the instance size, choosing it, your type of database, the target cloud, and so on. In the bottom section, you could put your username, the default collection name, and that will get created. Select a shard key. If you have a key, you'll provide that. If you just want to use automatically hashing the key, we'll just provision that from here. Go into the next step. Similarly, what we saw, if we have a parameter group created, we could use that. If not, we could just provision that without any parameters. Storage section, provision how much storage I want, enable the backup, and then I'm ready to go and say finish this provisioning a shard. Now we will see here that I have started provisioning a sharded cluster with the 3 nodes, 1 config server, query router, and a data node. I could always add. Now let's see how, while this is getting provisioned, let's go and see on the existing shard some of the actions and the management functions which are made available. On this shard, I can go and add collections. So you could see in the bottom I have the default collection which we had requested for, that got created. But if I wanted to create other collections, I could do that. I can add users, similarly modify database, terminate, and so on. I can add shard. So adding a shard would automatically expand that sharded cluster and add a shard node to it. So I can start adding a shard now and then start growing that. Now you would see the number of nodes has gone to 4, and we would see here in the events tab it will start adding a node to that cluster. On the replica set, I started off with a single node and I added replica nodes to it. I can do a add node, remove node, as I told you that the minimum requirement is having a 3 node replica. If you have more, you could remove the nodes. So basically you could grow and shrink on demand as you needed. Modify action is similar, where you could specify your backup configuration, provide your parameter group, and configure the databases. Similar to the backup option, there's an automatic backup, and then you could always take a Mongo dump right from here, create a dump for a given database, and create that. In the bottom section, as you would see here, the access information is available under access details for the database. User can pick this information, and there's a primary and secondary nodes which are exposed. The database information is available. The collections we saw. If the users are created, you see the user information here. The log information for the database is available. Similar to that, you can get the log on screen or download the log file. In the monitoring section is where the default monitoring is provided, and get a view into your database and fine tune it based on your usage. So you could pick up any of these parameters and zoom into it, zoom into a particular time window and see what was happening then, and look at the more granular time and up to the 24 hours data on the monitoring section. In the parameter group, similar to the SQL database service you saw, there is parameter groups you could create and set the values. Now, using this pre-creating some parameter group gives you the option to provision your certain database nodes with that capacity, with that configuration, and have it available for your application. If you don't have anything pre-created, you could always, like I said, the default options will apply, and the database will get created with the default options, and you could fine tune it as you go from that. So we also have integration with MMS available. So under MMS agent, user can provision MMS agent and add, providing their MMS keys, and add that agent. Once the agent is created, it can be added, it will get registered on the MMS console, and then now you can log into your MMS console and register your instances, the Mongo instances provisioned within Cumulogic on MMS, and get that additional instrumentation, the monitoring and analytics data on MMS itself. So that was a very high-level view into the Cumulogic, all the functionality and features available on the Cumulogic SQL and NoSQL database service. I think we are almost about time. I will hand it back to Jack for opening it for questions.
Thank you very much, Sandeep. That was a great presentation. We do have some questions that have come in from our audience, and it would probably be worthwhile if we ran through these rather quickly. So with that, let me get right to them. First question is, what approach is Cumulogic taking to multi-tenancy in the platform?
That's a good question, Jack. I'll take that. So the way that Cumulogic works is that each node of any service that we're deploying is deployed as a virtual machine under the underlying infrastructure, or in the case of a bare metal environment, it's deployed as or allocated as a single bare metal server. And so what that means is that we're not pushing databases out into the infrastructure where even the guest operating system is expected to handle multi-tenancy. So we take advantage of the underlying tenancy models of the IS stack. The second thing we do is we make sure that because of that configuration model, we are able to work with the infrastructure to enforce network firewalling and access control lists, and let the end user actually decide who's going to get into the environment, into the database, and who's not, very, very easily.
Thank you, Chip. Appreciate that. Participants, I want to encourage you to submit questions. We do have a few more that have come in, but you do have another minute or two to submit additional questions. Gentlemen, what are the infrastructure requirements to make this solution work?
I'll take that. Very easy. I mean, having a Cumulogic controller setup is very small requirement. You can run it as small as one single virtual machine. Say, I would say a 4-core 8 gig virtual machine running CentOS, and point it to your controller for a production deployment. We recommend that kind of setup for during your POC or testing phase. And for production deployments, you could deploy that into a multi-node, like a active, passive, primary, and failover deployment, where you could have 2 virtual machines and a clustered database in the back to deploy. So, setting up the controller is very straightforward. There's an installer available that can be downloaded, and we work through the process with you to install that and make it available to your users.
Wonderful. Thank you, Sandeep, for covering that. Another question, what is the licensing and pricing model for service providers?
I'll grab that one. So we actually have 2 options available for the provider. The first one is really intended as almost a starting point, or in the case of some providers, it's appropriate because they're doing a lot of dedicated private clouds for their end users. And that's based on a per socket annual right to use fee. Now, the sockets that are being measured here are actually the size of the target infrastructure cloud. And so what that means is you would install the Cumulogic controller wherever you want, but what we're going to be working with you on licensing is the right to deploy database services within a particular infrastructure environment. And so we'll look at the total host count and total number of sockets available on those hosts. So that's one model. Now, the second model is a usage-based model. And with that will come a minimum monthly commitment first, and that will get you, depending on how much you commit monthly, a certain number of deployed virtual machine hours. And remember, go back to my answer to how do we handle multi-tenancy. Since each node of each service we deploy is in fact a virtual machine, what we'll do is we'll work with you to measure the total number of hours that virtual machines created for the Cumulogic controller, by the Cumulogic controller, are actually online over the course of a month. And so with that minimum commitment, you'll get a certain number of those VM hours, and then there'll be a per VM hour charge that once you go over what that minimum commitment buys you.
Thank you, Chip, for thoroughly reviewing that. I have a couple more questions here. We'll get through those rather quickly. One question is, could you, and these kind of go together, gentlemen, could you again state the current database engines that you support and those that you have planned to release in 2014? Is that question clear?
Absolutely. Sure. So within our relational database service, we support MySQL as well as Percona, the Percona-as-a-Service engine. Within the NoSQL service, we support both MongoDB as well as Couchbase. Currently on our published roadmap, we'll be adding both Oracle as well as Microsoft SQL Server support in Q3 of 2014 to the relational service.
Thank you, Chip. I'm just going through the questions pane here to make sure we've answered all the questions. And I do believe we have. Participants, I want to thank you for submitting those questions and being very engaged and interactive with us. With that, we're going to move to the close. So I want to thank everyone for joining us today, tonight, wherever you may happen to be. As a reminder, you will receive an email with the link of today's presentation within a 24-hour basis. Also, we'd love to hear from you directly. If you want to contact us, please and keep these conversations going, please feel free to email us at info@cumulogic.com. We'll be very responsive in responding to any follow-up that you may be interested in. On behalf of our presenters, me, everyone here at Cumulogic, we greatly thank you for your time today, this evening, and we hope to be engaged with you in the not-too-distant future. Thank you all. Goodbye.